Let's check out another disorder structure from the Jaca datasets. 03. I'm loading the structure, and what have we got? We have got cadmium. This looks like a cadmium complex. The cell 7, 10, 11. I over sigma looks pretty good. Resolution is quite high. It's merged data. I'm not sure why it's merged, but that doesn't matter too much. Let's solve it. Solve the structure. Shell XT gives us the atom type assignment of sorts. I suspect that that is an oxygen. So it just, let's just refine it so it's maybe easier to follow. So Control M will also tell us a few things here. So first of all, obviously this could be an ammonium, but it's almost certainly a water molecule. And this one here will be a nitrogen atom, and then we may have a nitrogen in that ring. So let's refine this a few more times. Refine 12. We can set it to 12 cycles. It won't do 12. It's not required if it's not required. That looks more or less done. Let's make it anisotropic, anis. Or of course you could always go to toolbox work and press the anis button here and refine it. Control R on the keyboard. Right, so that looks pretty good. 3.92% R factor. We can see all these hydrogen atoms here. So a standard HAdd will probably do a good job in adding all of these hydrogens here. Let's refine it a few times and see where we end up. Right. Okay, so we have virtually nothing left here. However, that all looks very clean here. There is clearly some disorder going on in that CH2 thing here. So what I'm doing is, first of all, kill $H, get rid of the hydrogens if you're doing the disorder modeling. And then what we want is this turned over upside down. So I'm selecting both of those, and in toolbox work mode, disorder tools split. And all I'm doing is I selected those two and then I'm moving them. That's it. So I want one up there and one down there, just with the greenness in the map. And we're done. So this was that. We might as well add some hydrogens at that point here, HAdd, and we have done that. And Control, it's only one. It only added one hydrogen to this nitrogen. I'm not quite sure why that is, because really there should be two, one that belongs to this and one that belongs to that. What happens if I do HAdd here? Nothing. So I suspect the distances here aren't quite right. 1477, 1479. So they are very much the same. So what we can do, just to make sure, we can select SADI, make it quite strong because they really have to be the same here, and hopefully this will sort this out in such a way that those distances are now better. Now we can't do the HAdd if there's already one there, so we delete that, and HAdd now adds the two hydrogens that we expect. So we can look at part 0 and part 1, and these are correct, and we can look at part 0 and part 2. So that's the other part, and that looks pretty good. Okay, so we're looking at all the parts again, make it anisotropic and refine it. And hopefully this is pretty much it. That's all we need to do to solve this disorder here. This is still showing as a thing, so it should be CH and then alphabetical. So I wonder what's different here. The hydrogens, so the number of hydrogens was wrong. I think this is correct now. So this, to me, you can do Control J if you've got Report Plus installed, and can see whether this goes somewhere. Yeah, this grows. Yeah, so this grows into this thing here. So we've got this nice dimeric complex here. This is quite nice. We can do H-tab as well, just to follow the hydrogen bonding. It is not applicable in a grown structure, so we need to do fuse first, H-tab, and then the hydrogen bonds will be listed in the CIF file and evaluated. So we're nearly done. Obviously, CIF file, we need actor on to get a CIF file. We haven't got that. We need to switch the weighting scheme on to make sure that the goodness of fit becomes reasonable, i.e. close to 1. And let's just do this a few times. Hopefully the shift will have settled. The goodness of fit is still is good. So, but the weighting scheme is still showing us a bit of red here. We can click on this and then we should see what's moving. We can't see what's moving, so the listing page up will tell us. No, it doesn't actually tell us in this view. It's interesting. Right, so refine this a few more times and then this will settle. Now, okay, I'm giving it 24. It just needs a few more cycles to settle completely. And hopefully now it will be settled. Now let's look at the FOps FCalc. There's a couple of outliers and maybe there's a little bit of extinction going on. Let's try that as well to see what we are getting. So the value here comes out as 73 with 10, so that's definitely valid. That should look more straight, and it does. Well, it's an outlier. It's a very weak reflection. It's not going to make much difference. We can also check for outliers over here, bad reflections, and there is nothing showing. Right, so one last refinement set, and I think we are done with that structure. Final grow, so we see the whole grown thing, and now you might want to hide these the disorder. We can go cell part 2, so we're selecting everything in part 2. Cell atom bonds, that selects all the bonds to the atoms. So all the bonds that are involved in the disorder should be selected, but it didn't select those ones. I think there was is it -T? No, -A. Yes, -A. So cell atom bonds -A selects all of the connected bonds, and now we can group them. Group -N equals, you can give it any name you like. Let's call it, I don't know, P2 for part 2, name -N P2. So the default style is that sort of, nasty green, but you can right click on this, graphics, draw style, and you can select something more pleasing. So let's say I'm selecting this gray, and I'm also selecting a gray for this, and I'm making it translucent, let's say 40%. And if we do that, then you can sort of see the shadowy background, so you can see it's there, and that might sort of signify it's disordered here. Let's try this again. I'm changing the draw style, and I'm also putting on the blending. I don't remember which way it runs, either 80 or 20, but with gray we won't see. So the original color of the atom shines through. So this now looks pretty good to me. And if this was a nitrogen or oxygen, you would still just about see this. So this name is now remembered. So the next time you want to use this, you just go group -N equals P2 for part 2. And you will have your style for making a picture. So clear does that. And of course you can head over to draw, and then to bitmap images, and you can select the size. So this will be a 1200 pixel width image, but you can make this any size you like. You can type in the size you like and then just go. Or you can just press Ctrl P, and that will also make that picture. And I'm going to demonstrate this in a minute. If I just go Ctrl P, it now says it already exists. Do I really want to overwrite this? So that tells you it's done the right thing. Thanks for using OLX2.